Imagine you are building a huge Lego city. You have thousands of Lego pieces, and every piece needs to be connected correctly. If you have to find, connect, repair, and organize every piece yourself, the work becomes very difficult. Java applications can face the same problem when they become large. We have many classes, objects, databases, and services that need to communicate with each other. This is where Spring Framework comes in. Think of Spring as a smart Lego organizer. It helps us create and connect objects, manage their relationships, and organize our application. So instead of spending most of our time managing connections, we can focus on writing the actual business logic. Before Spring became popular, Java developers often worked with technologies such as EJB, JNDI, and JDBC. These technologies were useful, but developers often had to write a lot of repetitive code. We call this kind of repeated code boilerplate code. Imagine carrying a huge stack of books every time you want to study just one topic. It works, but it is tiring and inefficient. Developers also faced complicated configuration and maintenance problems. Spring came as a rescue. It helped reduce unnecessary code, supported modular application design, introduced powerful dependency injection, and simplified database access. In simple words, Spring tries to remove the boring and repetitive work so developers can concentrate on solving real problems. Now let's understand two important ideas: lightweight design and dependency injection. Lightweight means Spring does not force us to use heavy technologies for every small task. Think about going to college with a small backpack containing only the books you need. You don't carry the entire library. Dependency injection is another important idea. Suppose a car needs an engine. Without Spring, we might manually create the engine and give it to the car. With Spring, we can simply tell Spring that the car needs an engine, and Spring can create and provide it. So Spring manages these connections for us. The result is less code, easier maintenance, and loosely connected components. Here we have two important Spring concepts: IoC and AOP. IoC means inversion of control. Normally, our Java program creates and manages objects. With Spring, the framework can take over that responsibility. Think about ordering food at a restaurant. Instead of cooking everything yourself, you tell the restaurant what you need, and the restaurant prepares it for you. Spring works in a similar way with objects. AOP means aspect-oriented programming. It helps us handle common tasks such as logging, security, and transactions separately from our main business logic. For example, instead of adding security code to every single method, we can manage security as a separate concern. This keeps our main code cleaner. Let's imagine a bank transfer. We need to remove money from account A and add it to account B. What happens if the first operation succeeds, but the second operation fails? That could create a serious problem. Spring's transaction management helps us handle such situations. If an important step fails, the transaction can be rolled back so the database does not remain in an incorrect state. Spring also simplifies JDBC programming. Normally, JDBC requires repeated code for connections, statements, and result sets. Spring provides tools such as JDBC template to reduce this repetitive work. Spring can also work with technologies such as JPA, Hibernate, MySQL, MongoDB, REST APIs, and cloud platforms. Now let's understand Spring's modular architecture using a school example. Imagine a large school. We don't ask one person to handle teaching, accounting, reception, database records, and examinations. Instead, different departments have different responsibilities. Spring follows a similar idea. It is divided into modules, and each module has a specific job. The web module handles web applications and users. The data module communicates with databases. The AOP module handles common tasks such as logging and security. And at the bottom we have the core container, which is the foundation. Other parts depend on this foundation. This modular design allows developers to use only the Spring features they actually need. Think of the Spring core container as the brain or engine of Spring. Without it, many important Spring features cannot work. Its first major responsibility is creating objects. Normally, we write something like new student. With Spring, the framework can create and manage that object for us. These Spring-managed objects are called beans. The container also manages dependencies. For example, if a student needs a book, Spring can provide the required book object. Another responsibility is managing the bean lifecycle. Spring can decide when an object should be created, used, and destroyed. Finally, Spring provides the application context, which acts like an office that knows where the application's beans are located. This slide introduces two important Spring areas, AOP and data access. Think about teachers entering a classroom. Before teaching, they may need to perform common activities such as checking attendance or unlocking the classroom. Instead of every teacher writing the same code, one helper can handle these common tasks. That is the basic idea behind AOP. It can help with logging, security, and transactions. The Data Access module has another responsibility. It communicates with the database. Spring provides JDBC support to reduce database code and also supports ORM technologies such as Hibernate. Transaction management can make database operations safer by ensuring that related operations succeed or fail together. Now let's look at two more parts, the web module and the test module. The web module is like the reception desk of a school. It receives requests from users and helps the application respond. Spring can be used to build web applications and REST APIs. It also supports the MVC pattern, model, view, and controller, which helps organize application code. Now imagine a quality checker in our school. Before launching software, we need to make sure everything works correctly. That's the job of the test module. Unit testing checks individual components, while integration testing checks whether different components work correctly together. Spring works with tools such as JUnit and Mockito for testing. Let's put everything together. We can remember Spring's architecture using 5 simple characters. First, the core container is the brain or engine. It creates and manages objects and their dependencies. Second, AOP is the invisible helper that handles tasks such as logging, security, and transactions. Third, Data Access is the records office that communicates with the database. Fourth, the web module is the reception desk that handles websites and REST APIs. Finally, the test module is the quality checker that verifies whether our application works correctly. Here is our simple memory trick. Core creates, AOP assists, data stores, web communicates, and test verifies. Why do developers like Spring? Let's look at 3 advantages. First, Spring reduces coding effort. Instead of manually creating and connecting many objects, Spring can manage them for us. It's like using a ready-made cooking kit instead of preparing every ingredient from zero. Second is loose coupling. Imagine a car. If one tire is damaged, you replace the tire instead of replacing the entire car. Similarly, Spring helps us design components so they are not unnecessarily dependent on each other. Third is easy testing. If components are loosely connected, we can test one component separately without starting the entire application. So Spring helps us write cleaner and more testable applications. Spring provides several more advantages. First is better maintainability. In a large project with thousands of files, good organization makes it easier to find and fix problems. Second is modular architecture. You don't have to use every Spring feature. If you only need database access, you can use the appropriate module. Think of a pizza. You choose the toppings you need. Third is enterprise readiness. Spring is suitable for large applications such as banking, e-commerce, healthcare, and cloud-based systems. Finally, Spring has a large community. If you face a problem, you can find documentation, tutorials, blogs, videos, and developer discussions. This makes learning and troubleshooting easier. This slide gives us a quick revision of Spring's major advantages. Reducing coding effort means Spring handles repetitive setup work for us. Loose coupling means application components can work more independently. Easy testing means we can test individual components without depending on the entire application. Maintainability means organized code is easier to understand and update. Modular architecture means we can select the features we actually need. Enterprise readiness means Spring can support large and complex applications. And finally, large community support means developers have access to a lot of learning and troubleshooting resources. If you remember these 7 advantages, you already understand an important reason why Spring is widely used. Before we finish, let's review the important vocabulary from today's session. Spring Framework is a Java framework that makes application development easier and more organized. IoC, or Inversion of Control, means Spring takes responsibility for creating and managing objects. DI, or Dependency Injection, means Spring provides an object with the dependencies it needs. AOP, or Aspect-Oriented Programming, handles common concerns such as logging, security, and transactions. The core container is the foundation that manages Spring Beans. The web module helps us build web applications and REST APIs. The data module simplifies database operations. And the major benefits are less coding, loose coupling, easier testing, better maintenance, modularity, enterprise support, and a large community. Let's finish today's session with one simple definition. Spring Framework is a lightweight, open-source Java framework that simplifies enterprise application development by providing dependency injection, inversion of control, modular architecture, and support for web applications, database access, testing, and other enterprise features. If this sounds complicated, remember our Lego example. Without Spring, we manually find, connect, organize, and manage every Lego piece. With Spring, we have a smart helper that manages much of this work for us. So remember this formula. Spring equals less code, better structure, easier testing, and readiness for large applications. Now you are ready to start building your own Java Lego city with Spring.